So, what have we done for the last week or so? What kind of things did we do? Exponents. Now, did we deal with variables most of the time or with numbers? Most of the time with numbers, okay? And what kind of rules did we discuss? We discussed the rule for multiplication. After it, we division. Hold on. Multiplication, division. Then what? It doesn't have to be in the same order we did. What else as well? Two rules so far. Multiplication, division. What else? Come on. The case of 0. The complicated base, either multiplication or division. The rule of what? 0. And then, come on. The rule of what? Come on. When do you flip? When you have a what? When do you flip? Whether an integer or a fraction. When do you flip? When you have a what exponent? When you have a negative exponent. And the very last rule, a power inside of another what? A power inside of another power. Okay? So all of these rules now are going to be applied to what? To what we call exponential. Exponential what? Exponential relations or functions And we're also going to learn how to what? How to sketch their what? Their graphs without needing what? Desmos. Or I mean, today I'm going to give you a nice grid and with the exact numbers and so on. But in general, I will teach you how to sketch it really quickly without needing a ruler or calculators or anything. Okay? All right. So an exponential relation is a what? Is a relation or a function. Let's say a function. Go ahead. A function that involves, like has in it. Again, what's the name of this unit? Exponent. So it's a function that involves exponents. It's a function that involves exponents. Exponents. Here's a question for you. Who remembers this function? Everyone? Who remembers this? Eyes on the screen. Who remembers this? Raise your hand if you remember this. Okay, good. We have a good number. Rexile, what is that? Very common in grade 9 and 10 and you know what, 11 as well, but we tend to focus on other things. What is that? Come on, shh, go ahead. Like, what does this describe? If you want to sketch that, what would it lead to, if you know? Do you want to say or no? Who knows? Sorry, not who knows. Who would like to say? Come on. What does this represent? Okay, yeah? Okay. Uh, I love that people, when they see this, they say what? Slope. Is this slope or is slope a part of this? Slope is a part of this. Can you tell me which symbol here? Everyone, which symbol represents slope? There's only one letter in all of math that represents slope. Which one of these? M. M is the slope. I agree. So M is the slope. But what's the whole thing? If you say M is 5 and B is 7, so you say Y equals 5x plus 7. What is that an equation of? A straight what? A straight line. Okay. Would this be a line or a curve? We just said it's a what? It's a line. Everything is either a line or a what? Or a curve. If it's not a line, it must be a what? Must be a curve. Can you call this an exponential relation? Does this involve an exponent? Who says that this involves an exponent? And by the way, if you say yes, you have to tell me what the exponent is. Come on. Sure. Hala, go ahead. Where's the exponent here? Okay, Shadi. B. Y. Okay. In general, everyone, all of these have what power? Is one an interesting or not an interesting power? Not exactly. That's why we do not call this what? An exponential relation. Okay? If the power is what? Is other than, okay, who knows this one? What if I said this? What if I said this? Who remembers this one? And if you don't remember it, that's fine, because I will reteach you the whole thing probably in a couple of weeks. Who remembers what this is? This has two names, by the way. One name that starts with Q, one name that starts with P. It's not okay. One of them describes the math, and one of them describes the shape. Okay, Hamza, what do you call this? A quadratic. Okay? Yeah. A quadratic, when you see the math. When you sketch it, what do you call the sketch of any quadratic? Starts with a P. Parabola. Parabola. Like when you sketch it, you call that what? You cannot call this a parabola. This is a what, Hamza? This is a quadratic. When you sketch the shape, Kareem, the shape is called a what? A parabola. You cannot call the shape a quadratic, and you cannot call this a what? A parabola. This is the quadratic, and when you sketch it, you call it a what? A parabola. However, can someone tell me what if I do this? What just happened here? Come on, what did I just do to the one that was just written? I did what? So the x was the base, and the 2 was the what? The 2 was the exponent. Now what happened? The 2 now is the what? Come on, the 2 is the what? The base, and the x is the what? And that is what we call what? A what? An exponential, or an exponential what? So all you have to know that an exponential relation, which one has to be the base? The x or the number? And what has to be the top? The what? The x or the variable or the y or whatever. Okay, so always know exponential means number down, variable up every single time. Okay, so let's actually what? Let's talk about the structure or the anatomy, if you will, of what? Of this thing. Okay, what do you call the y? Is it the horizontal or the vertical axis? All the time. Say again, the what? The vertical axis. Here's my other question. Is y the output or the input in any math you ever do? Especially if it looks like this. Come on, people. Which one of those two is the input and which one is the output? I have a very easy way to let you know which is which. Shadi? Y is the what? Output, which means x is the what? How do you always remember that x in this way is the input? Which one is inside the bracket? X. Whichever one is inside becomes the what? Becomes the input. So go ahead, and this will be what will be the input. Sorry. Input variable, which means this will be what? The output variable. Yeah, go ahead. The output variable. Okay. What do you call the small b? What do you call the small b? Come on. What do you call the number that is basically at the bottom, not at the top? The top one is called the exponent. From day one of this unit, day one, what do you call the b? Anything that is basically up below the superscript is called the what? The base. So b here will be the base, which has to be a what? A variable or a number. What did we just say? Has to be a number. Must be a number. Must be number. Okay? Again, everyone, this is for this part. It's not here. Okay? Okay. What do you call all of this? Technically, what do you call f of x? It's on the top. So what do you call it? Come on. It's on the top. What do you call it? Exponent. However, this exponent is also a what? What do you call any f of x? You call it a what? A function. So you can call it what? The exponent function. Okay? So exponent function. What's the last thing we have to identify? Come on. We identified the y, the x, the f of x, and the b. What's the only thing missing? A. What do you call the a? Okay? Everyone, again, because this is technically going to be touching up when we do quadratics. Who remembers seeing things like this from grade 10? Come on. Again, what do you call that, Hamza? It's another quadratic. By the way, how can you always tell it's a quadratic? The highest power is what? 2. Okay. Do you know what we call the numbers 2 and 3 and technically 1, but at least 2 and 3? Do you know what we call numbers always before a variable in any math course you ever take? Some of you might have heard the word, but I just want to see who remembers it. What do you call the number that is right before a variable? Multiplying it. I'll give you it. Starts with a C. Yeah, coefficient. Coefficient. So this one is called a what? A coefficient. Okay? So it's one word. Coefficient. Sorry, I'm drawing a blank. IENT. My bad. Okay, that's it. That's the anatomy of this equation. So let's write. Yeah, what's up? Okay, hold on. So Rauda's asking, does this base have to be a what? What was your question? Did I say a whole number or did I just say what? Number, which means what? It could be a whole number or a what? What's the opposite of a whole number? Fraction or a decimal. Thank you. Yes. So let's actually now what? Explain quickly what each one is. Okay. So actually, you know what? I'm going to save you time. I'm going to show you what it is. And there we go. So let's copy this down. And as you copy, I'm just going to talk. So I'm just going to zoom in as well. So your y, as Shadi said, would be the output, and your x would be the input. What did I call the a? I know I called it coefficient, but here I also called it another thing. What did I call it? No. Yeah, go ahead. What did I call the a? Come on, the middle one. What did I call it? Initial value. Does anyone know what's initial? What does the word initial mean? Even in English, but especially in math as well. Come on, people. What does the word initial value mean? Say again. First value, exactly. So this is a means initial value, which means it's the first value of the function. I'll explain what that means in a bit when you start sketching. By the way, the idea of initial value, everyone, is very important because after this unit, after exponents unit, we're going to do a unit that depends a lot on exponent called finance. How many people have heard of something called compound interest? Compound interest. Any hands up? Yes, compound interest is so dependent on what? On the initial value of how much you owe or how much you invested. Okay? Yes. Sure. Okay? And as everyone said, b is base and fx is the exponent function. Now, what are the restrictions here? Your y can be any number. It could be positive. It could be negative. It could be an integer. It could be a decimal. It could be a fraction. Okay, how about the x? Same thing. It could be positive, negative, integer, decimal, fraction. How about your initial value? So far, it seems that all of them could be anything to Rauda's point. Aha, except your base. Your base can never be what? It only has to be what? It can never be negative. And I'll show you actually why it can't be negative once you're done copying this. Okay, everyone, let me go to Desmos. I'll come back to this, don't worry. But let me go to Desmos and actually see you, tell you what I mean, or show you. Okay, I don't need this. Okay. Desmos, yes. Okay, everyone. I am going to write, everyone, I'm going to write the equation here. Y of what? Come on. Y of what? Y of x equals, what was the first thing? A, and then bracket, B, and then on top here is f of x. Okay. All I care about today is this B. Okay. Noor, give me any positive number you want. Has to be positive. 10? Sure, 10, no problem. So everyone, Noor gave us 10, so I will write y. By the way, just so you know, when you do things in Desmos, you do not have to write y of x. You can just write what? You can just write y. It understands that the input is whatever appears on the other side, which is going to be an x. So y, everyone, y equals. Okay, Amr, give me a number for the a. Anything you want. 2. Okay. 4. All right, 4. And Noor, you said what? You said 10. And for today, everyone, we're just going to make the fx just an x. So I do shift that and x. All right. Ooh, my bad. Oh, sorry. There we go. Okay. Is this a curve or a line? That's definitely a curve, right? Okay. Is this an increasing curve or a decreasing curve? How many people say this is decreasing? Say again? It's a, okay. Why would someone say, no, I can see it as decreasing? Interesting. It's on the left side. Okay. I've never heard that before, but I'm glad you brought that up. What's another reason that someone could say this is going down? This is a curve that's going down. Okay, Haley, go ahead. Yes, someone could say, everyone, how many people say this is increasing? Don't change your answer. How many people say this is increasing? Why? Because if you slide on it this way, are you going down or going up? Okay, how could someone say it's decreasing? How do they have to slide? They have to slide this way. can you ever travel on anything in the XY grid from right to left? Which way do you always walk? Which way do you always travel in the grid? You always start from where? Left side, and you always have to make your way to the what? To the right. You never travel the other way, which, by the way, is a common mistake of so many even grade 12 students. They say, no, I can see this as going down. Why? Well, you could travel on this way. You are never allowed to go from this side of the grid to this side of the grid. So you only go from where? Come on, left to right. The only way then to trace this one is to go what? Up or down? Up. Okay, that's fine. Okay, here's my question. Noor, you picked 10 for the base, right? I want you now to pick a negative number for the base. -4. Sure, no problem. Okay, everyone, we're ready? Noor is telling us to make the base -4. Okay. You ready? Everyone, look at the screen, see what's going to happen. What's going on here? Okay, hold on. But is this a curve or just a bunch of dots? Oh, we're looking at the screen. Yeah, so that's my point. Did we generate a continuous connected curve or a bunch of dots? Okay, you know what? You know what, everyone? Let's play devil's advocate. Let's say that Noor, you know what, shows a negative value that's really bad. Let's say maybe another negative value would be good. Muhammad, give me another negative value. And by the way, it could be anything you want. It could be a negative decimal, it could be a negative fraction, or it could be a negative whole number. -6. What am I still making? A bunch of what? Okay, give me a negative decimal. Anything you want. By the way, everyone, just so you know, when I say decimal, I know that so many people think when you say decimal, you think of a number between 0 and 1, like small, like 0.3. A decimal just means what? A decimal just means a number with a decimal point. So it could be 7.6. Okay, but so many people think decimal is smaller than 1. Well, technically it could be, but it doesn't always have to be like that. Say again? -9.5. Again, a bunch of what? Okay, now let's what? Let's choose a positive number. Let's make this a positive one. What just happened? The dots have been what? Connected. So what do we conclude from this? Can your base ever be negative? Can it be any positive number you want? Yes. Can it be 0? What do you think? If I make this 9.5 as 0, it could. But here's the interesting thing. What's 0 to any power? What's 0 squared? Like 0 times 0. No, 0 squared, like 0 times 0. Remember, when you multiply 0 by anything, you just get what? What's 0 to the power of 3? Like 0 times 0 times 0. So that means what? If I make this 0, all my values would be what? Do you see the line? Where is it? Is it up, down, or right at the 0 level? Right at the 0 level. By the way, does this qualify to be a curve, or is it still a line? See, when you have a 0, you can't call it an exponential curve. Okay. How about if you make it a 1? By the way, I'm just showing you the different cases. What do you think 1 would give you? What's 1 squared? Come on. What's 1 times 1? What's 1 times 1 times 1? What's 1 times 1 times 1? 1,000 times. So what does that mean? 1 to any power is still what? Okay, let's make it a 1. It's also a line, but where did it go? It went from the 0 level to the what level? To the, oh, it's 4 because there's a 4. But if I take the 4 out, where does it go? It goes to the what? To the level. Do you see what I mean? So 0 and 1 gives you what? Gives you just lines. So we don't count them. So that means what? Your value has to be what? A positive number other than what? 0 or 1. Okay. So now let's actually what? Let's go back to the notes and just look at this. Have we done this? Okay. Everyone. What can you tell me about the first curve? The one on the left. Is it increasing or decreasing? Increasing, because if you slide on it, you have to slide from here to here. How about this one? Look at the equation for each one. Can someone tell me what's the equation written on that one? What's the equation on the one on the left? No, no, no. Here's the equation. Here's the equation. Here's the equation. Y equals what? 2 to the x, or 2 to the power of x. What about that one? Equals 1/2 to the power of x. Which one is bigger than 1? 2 or 1/2? Which one is less than 1? 2 or 1/2? what do you conclude just by what I just said? If your base is bigger than 1, if your base is bigger than 1, what are you doing? You're what? You're going what? You're going up. If your base is less than 1, but still positive, you're what? You're going down. Okay, let's see. Again, let's prove it. Um, give me any value, Manel, give me any value between 0 and 1. But it can't be 0 and it can't be 1 because we just proved 0 and 1 give you what? Give you straight lines. Between the 0 and 1, so it has to be a positive small decimal. 0.7. Okay, everyone look. 0. What did I generate? Is this increasing or decreasing? Okay. By the way, everyone, let me show you this. There's an amazing feature on Desmos. Does anyone know the feature called the slider or no? Amazing. Don't write what? Look, do not write a number. Write a symbol. Ahmed, Noor, give me a symbol. Basically, any name for a variable. Doesn't have to be X. Anything you want. By the way, you cannot use X because we're already using the what? You're already using the X. Just give me any variable name you want. You have 25 letters left of the English alphabet. What do you want? A. Sure. Everyone, look. I'm going to put A. You see what it asks you? Add what? Add slider. So you say, yeah, I'm going to add a slider. Because then you can what? Everyone, look. You don't have to pick a value every single time. You can just what? What does slider do? You what? You slide. You can what? You can now slide. And as you slide, what happens to this value? It what? It changes. It changes. So what did I say, everyone? What did I say? Your base cannot be what? Or what also? It cannot be negative. So that means what? Can I ever pick it to be negative 10? No. So I'm going to click on this. Everyone look. I'm going to click on here. Look. And I'm going to say I cannot be 0. I'm going to say I can be 1. Oh, sorry, 1. Okay, everyone. So I'm going to choose a value between 1 and what? 0 and? Okay, check this out. Look. Sure. You know what? Okay. 0 obviously is going to be a 0 line. Look, everyone. Look, eyes on the screen. Is the value changing? No, the value. Is the value changing of A? But is the curve ever increasing or is it always decreasing? Look, but what is it changing, by the way? No. What is the curve changing? Thank you. How spread out, how fast you're skiing down, right? But as far as I'm concerned, all of these curves are increasing or decreasing. See, okay, what's gonna happen when I hit the 1? Thank you. It flattens, it flattens, it flattens. Boom. See, that's what's amazing about the slider function. You don't have to keep writing point, point, point. You can just keep sliding. And there we go. Okay, now we're going to take what? Base is bigger than what? Bigger than 1, which obviously gives us what? A small collection or an infinite collection? An infinite collection. So now I'm going to say what? I'm going to go from 1 to, you know what? Let's go to 100. See all of the possible numbers from 1 to 100, of course. Okay, let's go with 1 again. Again, what does 1 give you? Okay, let's go slightly above 1. Everyone, look. Oh, you're right. Oh, thank you. Yeah, if you're 1 to 1, oh, sorry. Thank you. Nice. Okay, go. Come on. I don't know. Oh, step size is 100, which means it's only one step, like one shot. I'm gonna make my step size what? 1, like it jumps in 1, 2, 3, 4. But you know what? Let's make my step size even smaller. Let's make it 1.1, which means what? 1, 1.1, 1.2. Come on, keep going. 1 point. That's my point. You can decide to it how it what? How it changes. Okay? Like, do you want it to change it in steps of a big one or small one? Okay, so I'm gonna make it 0.1. There we go. Everyone, look. That's fine, but at least look. What's happening? Again, Shadi, what is it changing? The the shape or the curvature or the steepness. But all of them are what? Decreasing or increasing? By the way, what's happening as you go higher and higher? Does it become like an easy slope or a dangerous slope? Yeah. Imagine yourself skiing this way. What's going to happen to you? Well, you're not going to ski, don't worry. So what do we conclude here? Let's write the what? Let's write the conclusion. Okay. You see why Desmos is such an amazing tool for teaching yourself. So base is bigger than 1. Like what? Like 1 point what? I don't know. Maybe 1.01. I know it's small, but it's still bigger than 1. 1.1. Maybe 2.3. 413.7. Blah blah blah. Go ahead. Just write any examples of numbers bigger than 1, whether very close to 1 or very far from 1. Base what? What's this one? Less than 1, but still what? Positive or negative? Can your base ever be negative? It has to be positive. So I want you to say, but. Oh, sorry. This. Well, so it's 413.7. Yeah, thank you. You can put any number you want as long as it's bigger than 1. So I chose 1.01, 2.3, 413.7. How about this one? Base is less than 1. Whoops, sorry. But still what? Still positive, which means it has to be a small decimal, but you cannot put a negative sign. Like what? I don't know, 0.01, like 0.01, or sorry, 0.01, or what? Maybe 0.23 or 0.7. Can you give me a decimal very close to 1? Very close to 1. 0.999999 forever. So let's just say what? 0.99. My point is, do not touch the 1. Okay? All right. So if the base is bigger than 1, the graph is a what? Decreasing or increasing relation? Right there, left one. Increasing. Thank you. So right here, go ahead, right? Increasing. I hope we can fit increasing. Okay, let me just zoom in. Increasing. I'm just gonna squeeze it. Yep. Increasing relation. How about this one? This would be a what? Decreasing. Decrease, increase. Yep. Increasing, decreasing. Okay, everyone. One last thing about this page. Look at this one, everyone. Look at this graph. Can someone tell me what's happening to the graph as you go more and more and more to the left? Just look at that graph, the one I circled. What's happening as you go more and more and more and more and more to the left? It's going up or down. What does it seem to be touching after a while? Sure. The 0 line, or what do you call this axis? The what? The x-axis. So everyone, let's just write x-axis here. X-axis, just to emphasize. What was my question? My question, what does it seem it's going to touch after a while? And what did you all say? The what axis? Does it really touch it? By the way, on a sketch, does it look like it's going to touch it? Well, let's see what Desmos says. Everyone, here's my curve. And I'm going to go with a smaller, I'm going to go with a base of maybe, everyone, 3. Okay, what do? Do I move to the right or to the left? Come on. I want to move to the what? Everyone, eyes on the screen, to the left. Does it? Okay, by the way, to you right now, is it touching? Okay, let's look at it more closely. Is it touching really? Okay, maybe you could say what? Go left. Yeah, sure, no problem. All right, go left. Is it touching? But does it seem like it? Is it? Thank you. Does an exponential curve ever touch the ground? When does it really touch it? If you make it to the what? To the complete end of the what? Of the negative side. How far do you have to go? What do you call it when you keep going and never stop? What's the word? Infinity. But positive or negative? Because I'm going to the left. So no, I'm going to the left. No, I'm going to the left. I'm going on the left side. What does that? Okay, here's a question for you. Can you ever reach negative infinity? Can you physically actually get to the end of the x-axis? Which means what? Are you ever gonna see it touch? But when you sketch it, can you? You have to. Why? Because your no, because your pencil has a what? Has a what? Has a thickness to it. Does that make sense? But we know even if you make it touch the axis, is it really ever touching? Very good. Okay, awesome. So we can say what here? The graph is almost what? On the what? On the x-axis. But I want you to write what? Never touches. Never touches. Okay? Can someone tell me, would the same thing happen there? No, like on the right side. Is it kind of like the same idea? Yeah, but now instead of going infinitely to the left, you have to go infinitely to the what? Infinitely to the positive end of the things, or positively to the what? Infinitely to the right. Again, is it ever going to touch? No way. Keep zooming in. Keep moving and zooming in. You're always going to find a small what? A small gap, a small difference, a small height difference, whatever you want to call it. So again, the graph is almost horizontal on the x-axis as well. And again, it never touches. Okay? So now we know the basic features of a what? Of any exponential function. We know why it cannot be a negative base, because it gives you dots, and you cannot call a function dots. Or sorry, you cannot call dots a function or a continuous function. And you know it will never, ever touch the x-axis. By the way, question for you here. Everyone, look. Everyone, eyes on the screen. So here it's what? Here it's almost touching the what? How about this side? If you keep going this, what does it keep going? Up. Does it ever stop? No way. Never. What would it make it stop, right? Keep putting more numbers in, you get more numbers out, up and up and up. Same here. It will never stop increasing this way. Okay, everyone, flip the page. Oh, let me write x-axis here as well. All right. Okay, let's sketch one by hand. By the way, this will be a part of your test. You will be responsible for coming up with the values for the y values, not the x. I have to give you the x, and sketching it as accurately as you can. Okay, can someone tell me what's my function? It's just what? Y equals what? 2 to the power of? Okay, did I give you the x values? Yes, I did. So what do you do with each x value? Where do you actually put it in the equation? Instead of the x, you replace or substitute or plug in. All right. Now, obviously, you might ask, why did you give me such a large box for this? I want to show you the calculation. Okay, so what's my first one? 2 to the power of what? Okay, what's 1 divided by 4 as a decimal? I mean, you don't have to guess. You can just plug it in. 0.25, yes. 1 divided by 4.25. So my first value is 0.25. Okay, keep going. 2 to the power of minus 1, which is technically 1 over 2 to the 1, right? What is 1 over 2? Point. What's 2 to the 0? Come on, anything to 0. 1. 2 to the 1. 2 to the 1. 2 to the 1. 2. 2 to the 2. 3 would be 8. Okay. Obviously, there's no point of sketching more because where's the rest of the new math? All of it is the same. Okay. Now we have to sketch this. How do you sketch once you know the points and you have a grid? You just put the points on the graph. Okay. By the way, which ones of those values are going to be really annoying to sketch? The big ones or the small ones? Thank you. So you know what? Let's start from this side and then deal with that side when we get to it. Okay. When I'm x equals 4, how high is my y? All right. Let's zoom in, everyone. Here's my grid. I have to go how much up? 16. Well, I've already given you a decent grid. Look. Yes. By the way, can you all see the dotted lines on your graph? No, can you? I don't know. Okay. Okay. Good. Which because those dotted points go in values of what? In values of 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So can someone tell me where 16 is? Above what? Above 15. And this is the line for 4. So everyone, right here. Go ahead. Right there. 4, yeah, 4, you go up to 16. How about 3? You go up to what? 8. So on this line now, everyone, on this line, in this line, you have to go up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. Yes, 10 or 5 and sorry, or 5 and go up 3. How about 2? Where's the value for 2? 4. By the way, is this already looking like a curve? Of course, it has to. By the way, if it ever generates a line, you made a mistake or it's wrong. Okay. How about 2 to the 1? 2. How about 2 to the 0? Okay. Now we're going to get with the what? With the decimal. What's 2 to the negative 1? Where is half? How are you going to put half? How are you going to put? You have to put it on this line. Where is half here? Yeah. Yeah. Okay. So half is where? Between 0 and? Between 0 and what? Where is it? Right here? Right here. That's why I'm saying do the big ones first because the small ones are going to be annoying to do. So say again. Oh, do we connect? Yes, we have to. You. Oh no. We have one more point left. What's the last point? What's the last point? 0.25. Where is that? As close, yes, as close as you can get without what? Without, thank you, without touching the x-axis. And honestly, by the way, everyone, if your curve, when you sketch it, kind of looks like it touches it, it's okay. I know you didn't mean to, but you had to because that's just how like the connection of the line works. So I'm gonna put it right here. Even I have to kind of like get super, super close like this. Okay, how are we gonna connect this? Okay, everyone, listen up. One big mistake that so many students do when you ask them to connect this, you know what they do? They do this. Look, look what they do. They do this. Oh, you think I'm joking? And some of you will do that, even after I just said it. Is this a curve or a bunch of broken lines? I'm sorry, a bunch of broken lines doesn't make a what? Doesn't make a curve. So obviously, I know so many of you what did not connect curves before. So is it easy or hard? It's gonna be a bit difficult. Even me, with all my years of experience on the tablet, it's not gonna be easy. So you know what? Do your best. Just do not make it a bunch of what? Come on, do not make it a bunch of what? Broken small line segments. You have got to make it a curve. What if you can't hit all the points with your curve? That's fine. Just make it a curve. Okay? What's up? Can you what? Okay, let me see how I can do it. Obviously, everyone, I am right-handed, so it's probably going to be easier for me to start from the right side and go down. Okay, let me see what I can do. No guarantees here. Okay, hold on. Let me just finish mine. By the way, do you have to do it all in one shot? Absolutely not. Look at mine. It's already getting crappier as I go down. I know, but did I at least make it curve? Okay, you really have high expectations for nothing. Okay, now, everyone, technically, you have to show a little bit where above and a little bit below. How many people have seen math teachers do this? How many people have seen this? Please do it, because what does this mean? What does this and this mean? Is it? It keeps going. It doesn't really stop. Okay? You're just basically making sure that you know that it never stops going this way, and it never stops going this way. Done. You get full marks. I know it doesn't look perfect, but since when do diagrams have to be perfect anyway? Remember my triangles? They never looked perfect, but they still got the message. All right. Yes, I'll zoom out. Oh, you don't need this. Done. That's it. Okay, let's do the next one. Come on. Let's do the next one. Okay, let's come up with the numbers. Okay, everyone, here is the next one. What's my base? Okay, so I'm going to have to say what? 0.5 to the power of what? Yeah, you don't have to put the 0.5 in a bracket. I mean, you could if you want, but there is no need. Okay, what's half to -2? Surprisingly, look, it's how much? 0.5 to the power of 2. Sorry, not 2. It's what? It's 2 with a what? Negative. How much is it? 4, which makes sense because it's got to start high now and then go low. Okay, so equals to 4. All right, what's 0.5 to the power of -1? Yes, you're right. It is 2. So to the power of 1 with a negative. 2. What's 0.5 to 0? What's 0.5 to 1? No, no. 0.5 to 1. 0.5 or half. The number doesn't change. Can you tell me what's going on here? Everyone, compare this table. Hold on. Okay. Hold on, hold on. He's not fully wrong. What's going on here? Oh, sorry. What's going on here? What's my value here? No, no, here. Come on. 4. And then what? And then. How about this one? So what does that mean? Instead of going one way, it's just going the what? The other way. So exact. So what happens after 0.5? Because you went this way. Now you're going this way. So 0.5 squared is what? Is 0.25. And by the way, now it's going to get really, really, really annoying because the numbers are going to get really, really, really what? Small. Tiny, yes. So what's 0.5 to the power of 3? 0.125. By the way, do you think I'm going to be able to hit 0.125? No, I'm probably going to have to touch the axis. I know I don't mean to touch the axis, but it looks like it. What's the last one? Oh, sorry, not 0.4, 0.5. Oh, that's going to be even what? 0.0625. You're getting very what? Very, very small. Okay, well, let's try our best. Okay, which one do you think we should start with? The small values or the big values? Of course, let's get done with the big values first. They look cleaner. Okay, at -2, what's my value? Everyone, at -2, what's my value? +4, or 4 above the axis. Okay, so here it is. Where's minus 2? Minus 2. See that? Okay. I'll admit, everyone, that was stupid on my part. We're going to have to start sketching from what? But I already showed you what on the grid. Did we even use them in the table? Our table should have started at what? And then, you know what? That is fine. Let's sketch what we worked out. It's okay. No. You can you add more cells to your table? Of course you can. You don't need to. But that's my point. I should have, but I forgot. No problem. It's a mistake in the notes. Who cares? Okay. How high was it at minus 2? Come on. 4. Where is 4? 4 is right here. Okay. What's my next value? How high is it at minus 1? 2. 2 is right here. How high is it at 0? Anything to 0 is what? 1 by itself. So 1. Okay, these are the good values. Now I'm going to have to get what? Really, really low. So I'm going to have to get to what? To half. Half is like, yeah, is like half a square. And then, okay, at least now we don't have to connect as many points as the first one. Go ahead, let's connect. I might be right-handed, but it's actually going to be hard for me to actually start low and go high up on this tablet. I'm going to try my best to go down. Okay, so let's see. And I'm already going to start high up. Okay, look. It just has to curve. You can, thank you. You can flip the page. You can rotate. Just do anything to help you curve it the right way. Ah, that was a bad one. I need to go lower. Just give me 1 second. Okay. And then, damn, it's not. Almost. Oh. By the way, everyone, look. Everyone, what seems that I'm doing here? I'm going what? Seems that going, did I mean that? By the way, can it ever go up? Everyone, can an exponential ever go up? Can you ever, everyone look, would this ever, no, sorry, not this one. Would this ever go down and then go up? No way. What does that? Quadratics or parabolas. You go down and then you what? Is this a quadratic or an exponential? Exponentials either what? Start high and end where? Low, or start low and end. They never go up and down, and they never go down and up. The x squared. Yes, that's the parabola. So everyone, just go like this. Oh, what am I forgetting here? I'm forgetting this guy. That's it. Full marks. What's up? The little arrow? Yes, because what does that tell you? The behavior keeps going forever, both sides. I just don't have enough space to show it. You see what I mean? It's like you're telling me, by the way, this keeps going on forever. Okay? And even if you forget it now, I might not take marks off, but I need to prepare for grade 12. And math teachers always want to see what the trend going and going and going.